Alright, last but not least, we're going to talk about structures and properties of matter, objective number 4. And this is all about how temperature and pressure can change a solid, a liquid, and a gas. So I created some very, very basic sketches for you guys. These represent phase change diagrams. So as I increase temperature and time in a solid, eventually I'm going to get to a point where if I'm adding energy like heat, I'm going to actually melt that solid. So I have some ice cubes, I'm adding heat to it, eventually they're going to get to a point where they melt. When they're actually at that point, their temperature stays really consistent, but again, I need time in order for this to all happen. So as it's melting, I'm going to have, a little bit of solid, I'm going to have a little bit of liquid as it's melting, but eventually I'm going to get to a point where the solid turns completely into a liquid. If I continue adding heat, so here I'm adding temperature still, once I get to the next level, if I add enough heat, the liquid's going to start to turn to boil, or this can be called the boiling point or the evaporation point, either one. But as it boils again, that temperature stays constant. You just need time for it to all boil off. So I have a liquid at the melting point, a liquid here, and a liquid at the boiling point that could be present. Eventually, all of the liquid will turn into a gas, and again, the temperature can increase. So what's happening is more energy is being absorbed as we're moving up this chart. And what's happening in the particles is they're really tight and close together, but as I'm adding more energy, that more heat to it, it's getting those molecules more excited so that they can break those strong attractions and actually move more freely as they keep going up from each phase change. Just the opposite for when we decrease the energy. Energy is going to be released if we're decreasing it. So here I've got like my ice at the very tippy top, and we'll start at the top and work our way down for this one. So if I'm actually cooling a gas, eventually I'm going to cool it enough where I get to this condensation point. Okay? As it's condensing, what's happening is the gas is turning back into a liquid. So it'll take some time for that to actually all convert back to a liquid, and then if I keep cooling it or releasing energy, I'm going to get to a point where the liquid is going to then freeze. It's going to start turning into a solid. This is called your freezing point, and that'll take some time until it completely gets to a solid, and then if I keep cooling, I will be in the solid phase. So if I'm going down this chart, I'm actually losing energy, it's being released, and those particles are slowing down more and more, and that attraction force is going to kind of hold them together. So, in words, I have it in pictures and I have it in words. If I'm increasing the temperature, it's going to cause those molecules to gain that kinetic moving energy. So kinetic just means moving. And molecules will get or gain so much energy that they can break those attracting forces holding them together, and this will cause a phase change from a solid, a liquid, to a gas. Just the opposite. If I decrease the temperature, it's going to cause the molecules to lose moving energy or kinetic energy, and the molecules will lose so much energy that those attraction forces can overcome the energy and hold those molecules closer and closer together. So that would be going from like a gas to a liquid to a solid. The other thing that this playlist or this objective talks about is pressure, okay? And pressure affects changes of states by forcing the molecules closer together or farther apart, depending on which way you're looking at it. So if I increase the pressure in a room or in an area, it's going to cause those molecules to get closer and closer together. So if I'm in a gas state and I keep adding pressure and more pressure and more pressure, those molecules are going to get closer and closer together, And what could possibly happen is, or what would happen is the gas could then go to a liquid, and if I keep adding more pressure, that liquid could eventually turn into a solid because I'm forcing those molecules to go back closer and closer together. If I decrease the pressure, it's going to cause the molecules to actually spread out further and further. And this is really why water boils at a lower temperature when you're in a higher altitude. As you go up a mountain, a higher altitude, you decrease your atmospheric pressure, and so it's going to cause your molecules to spread out farther and farther, which means that you don't need a ton of energy to help that water turn into a gas because they're already spread out pretty much, or they're wanting to spread out more. So it takes a lower temperature to boil at higher altitudes. So that's just a pretty much basic thing on how temperature and pressure can affect how the different states of matter are changed.